Okay, so what we are saying is that we will try to find out our stresses which appear at this, which appear on this plane. So we can have normal stress and we can have shear stress. These are the two different types of stresses which you can have at any plane. So these are the two different stresses. Now what we do is we apply summation of all the forces must be equal to 0. That's all. So you have got one normal force which is normal to the direction of this plane, and one is a tangential force which is tangent to the direction of this plane. Yeah. So you have, so what we do is essentially we have to convert these stresses which are on the orthogonal faces. Okay, we have to take the component of these stresses along this plane. That's all we have to do. And remembering that this is equilibrium states that we need to have summation of forces must be equal to 0. So in order to convert stress into force, what we do is we multiply the stress with area. Okay, so assuming that this plane area is A, okay, so this one would be a cos theta and this one would be a sin theta. Okay, that's what we would have. And then after that, we can multiply that with the corresponding stresses and we will get forces. So let's see what's going on. A times stress, so this is A times stress, which is in this direction, is equal to stress xx times A cos theta. This is A cos theta, so this is the force. Okay, and this force, the component of this force in this direction. Okay, so you have to convert this force. This force has to be converted, okay, in this direction. So you have to take the component in this direction. So that component is this force times cos theta. This is cos theta, isn't it? This force component. So let me do it over here. You have theta and you have so if this is theta, this will be 90 minus theta. If this is theta, this will be 90 minus theta and this will be theta. Okay, so this is theta and stress x would be stress x cos theta. Is that understood or not? I've just done simple geometry. This is theta. So this is a triangle. This one is 90 minus theta. Yeah? And then we go into this red triangle, which if this is 90 minus theta, then this one is theta. And then stress, so this stress x times cos theta is our component, which is this. How about tau yx? So tau yx is in this direction. So again, we have to take the component in the normal direction. Okay, So this is this one theta and this is sine theta. So we take this triangle. This triangle has got theta, this is 90 degree, and so this component of tau is sine theta, which is shown over here. This is your sine theta. Okay, so what we are saying is, please remember that this is A times stress, which is in this direction. Whatever is in this direction means whatever is in this direction, that is positive. Whatever is opposite is in the other direction, that is negative. So look at this tau yx, which is so how would you have this one? What will be the component? Okay, so that's why this is negative. Isn't it? This is right, this is just from the resultant. Based on the resultants, you have got this one and that one. These two add up to give you that. Okay, so this component is facing in this direction. So, two things I have said. Okay, one thing is that you find out your theta, where your theta is, and then you assign the direction to it. So stress x is facing outward. I am saying that A stress is in this direction. So whatever on this side, whatever will be in that direction, away from this plane, that is positive. Okay? So this stress x is positive. This one, the stress y is similar. That will be positive. This one will be negative. And this one will be negative again. Okay? All their components are facing in this direction, in the direction of the plane. So that is negative. Agreed? Are you guys with me on this?
Yes.
Okay. So that's what. So you have got 4 stresses and 4 stresses are shown over here. Okay? Tau yx is A cos theta. So this is again the tau xy is A sine theta, which is this one, and I mean cos theta and sine theta, they are based on trigonometry. Yeah. So this is the normal. Now the tangential. How can we get the tangential? Now look at this one. The tangential for this one is like this and like that. Now the tangential one on this side must be opposite to the tau. So you can see that the resultant, which is this one, that is opposite to the tau. Sorry. The tangential A tau should be in this direction. Okay, so stress x times A into cos theta. Why cos theta? Because again the area, and then this one is sine theta. This is your sine theta. So the sine theta is in what direction? This is your sine theta. Okay, so that is positive again. Why is this positive? As I told you that this sine theta is opposite to this one. Now, so So what I'm saying is that if you have stresses in this direction on left hand side, okay, the normal stresses, the right hand side should be opposite to that of left hand side. Then you should it should be in the opposite direction to the left hand side. Okay, so if this is a stress which is facing in this direction, your right hand side must be facing in the opposite direction, okay, to equilibrate each other. Similarly, if you have the shear facing in this direction, okay, so it is facing downhill. So on the left hand side, this shear is facing downhill. So whatever stresses are facing uphill, they are positive. Yes, so that is your equilibrium. So stress X, so based on that you get all these four. Okay, 4 stresses, and you work out your right hand side. Now once you determine these two equations, then it's just algebraic manipulation. That's it. Okay, use some algebra to simplify these equations. So we know from our early knowledge that cos square theta is 1 plus cos 2 theta divided by 2, sin square theta is 1 minus cos 2 theta divided by 2, and sin theta cos theta is sin 2 theta by 2. Plug it in these equations and you get this form. Okay, all your cos 2 theta, sin 2 theta, so your equation comes in cos 2 theta and sin 2. So in the stress equation you get this one, and in the shear equation you get this one. So we can write that if this is 1, if this is 1 and this is 2, okay, so when you put these values you get 3 and 4 after putting this trigonometric identity. Now we are interested in finding out the theta which will give us maximum stress. So obviously when you talk about an equation which should give you maximum stress, we are talking actually about maxima minima. So we have to differentiate these equations with respect to theta. So what is that theta which will give me maximum stress? Okay, so what is that theta? Because obviously this is dependent on theta. What should be that theta which maximize this stress and the shear stress, the axial stress and the shear stress? Okay, so we differentiate this with respect to theta, this one. And once we differentiate that, so this is from 3 so this we get from 3 and this we get from. So you differentiate this one with respect to theta and equate that to 0. So you get the maximum theta. Okay? So you get tan 2 theta is equal to 2 tau yx. This is from 3. You maximize this one and you get maximize this one. And you get the shear theta, that plane which will give you maximum shear, and that plane which will give you maximum stress, axial stress. Please note, one thing is clear. Since the axial stresses and the shear stresses, the values are different, that tells us that there are different planes which gives us these stresses. In other words, it's not necessary that the plane which gives you maximum stress, maximum axial stress, will also give you maximum shear stress. Okay, that's important point to know. That it's not necessary that one form of stress, which is, for example, axial stress, okay, the plane which gives you maximum axial stress will not give you the maximum shear stress. Okay, the shear stress would be at different plane. So, and that's what you can see, because these two have come out to be different. Another thing to note is that the period of tangent theta is 180 degree. Yes, the period of tangent theta is 180 degree. After every 180 degree, it repeats itself. Yeah. So at one axis, so at one inclination, you will get maximum stress x, and at another period you will get minimum stress. So when we say maximum or minimum, what do we mean? What is maximum and minimum? Maximum or minimum axial stress can be maximum tension or maximum compression depending on your sign convention. For example, if you are saying that compression is negative, okay, and tension is positive, so stress max would be the maximum positive and stress min would be the maximum negative. Okay, so that can be your maximum minimum, or it can be the maximum positive, maximum compression and minimum compression, or maximum tension, minimum tension. So what I am saying is that this equation will give you maximum stress and minimum stress. Those stresses can either be in tension and compression, or they can both be in tension or both be in compression. Okay, so that you need to work out. It depends on the nature of the problem. Okay, but how can we say from this equation that you get maximum and minimum? You get one value which is of different one magnitude, another one is of different magnitude, by the fact that the tangent theta period is 180 degree. So the period, at one period you might get maximum value, and at the other period you might get minimum. Okay, so that is an important thing to note. So that's what I have written. That's why I have written over here maximum, minimum normal stress. So, but this is tangent to theta. This is tangent to theta. Please note, this is not tangent theta. It's tangent to theta. So the period of this equation is 90 degree. It's not actually 180 degree. Tangent theta period is 180 degree. Tangent to theta period is 90 degree. Because 2 times 90 is 180, isn't it? So tangent to theta period. So after every 90 degree, so the difference between the plane, the maximum stress plane and the minimum stress plane is 90 degree. It's not 180 degree. Okay, so what I have told you is that this equation will give you maximum axial stress and maximum and minimum axial stress. The axial stress can either be in compression or tension. Okay, so it depends on the nature of the problem. But because the tangent theta is a trigonometric function, and it changes its direction after a certain orientation, which is called period. So it has got period, and after a certain period it changes its direction, isn't it? So that tells us that at one period you will have one value, and at another period you will have another value. Okay, so one can be maximum stress, another one can be minimum stress. However, this is tangent to theta. Okay, so its period is 90 degree, not 180 degree. So after every 90 degree it changes its direction. So from one direction it will become another direction. Okay, and that is so after every 90 degree we get a plane which is a stress, a maximum or a minimum stress. So in other words, if you get at theta, at particular theta, you get a maximum stress which is in this direction, yeah, the other stress will be at 90 degree. Okay, and look at this one. Similarly, this is the shear. The shear is also equal to stress x minus stress y divided by 2 tau xy. Okay, that's equal to this one. So again the same argument applies on this one, that you will have maximum and minimum shear stresses, and those shear stresses are at a distance, at an angle 90 degree apart. So that is your shear stress. Now, to make your concept a bit more clearer, I've got this physical model. Now look at this one. Okay, what we are saying is, imagine I've got loads applied on this one and on this one, okay, and I make it, and it bends like this one. So I will get a compression, a maximum stress which is in this plane. Yes, can you see? This is expansion. Okay, it's the axial stress which is tensile in direction. Yes, but at 90 degree, this is squeezing. So I am getting compression. Okay, so one is at one plane I am getting maximum stress, and at the other plane I am getting minimum stress which is in different direction, and that's what is this equation is telling us. Okay, so physically also this is true, it works. Like if this moves like this, what happens is at a certain plane you get a maximum compression, a maximum tension, yeah, but at 90 degree you get compression, the maximum compression. In this direction you have got maximum tension, and in this direction you have got maximum compression. So that's an important thing to appreciate. Now it's straightforward. You just plug these values in this equation, okay, and you will get principal stresses. What is called principal stresses. So what is a principal stress? Principal stress is that stress where your shear stress is 0. Okay, so once you work out this equation, okay, and you plug it back over here, you will see that your tau yx, it goes to 0.